Hello everyone, class 12th. Topic is preparation of alcohol from grignard reagent. Firstly, we need to understand what is grignard reagent. The general formula is RMgX, where R is representing alkyl group like methyl, ethyl, cyclohexyl, cyclopentyls. These are alkyl groups which are represented by R here. Mg is magnesium. X is representing halide. Which halides? Like chloride, bromide and iodide. Why I am calling them halides? Because here X is carrying complete -1 charge. That's why I am calling them halides. Chloride, bromide, iodide. Mg is carrying complete +1 charge. Between Mg and X there is a ionic bond. And between R and Mg there is a covalent bond, means 2 electrons are present between them and they are getting shared. We know in R carbon is present and carbon electronegativity is 2.5 and magnesium electronegativity is 1.2. So due to higher electronegativity of carbon, electrons are more toward carbon side. That's why carbon is partially negative here. Now let's check some examples of RMgX like CH3MgBr. This part is working as a R, this Br is working as a X, Mg is magnesium. Between carbon and magnesium covalent bond is there. Due to higher electronegativity, electrons are toward carbon side and carbon is getting partial negative charge. Magnesium is carrying +1 charge complete. Bromine is carrying -1 charge complete. +1 -1, they are making ionic bond with each other like this. Now how this grignard reagent can produce alcohol? Grignard reagent individually can't produce alcohol. What it required? It required carbonyl containing compounds. Carbonyl group containing compounds. What is carbonyl group? COO. This group is known as carbonyl group. The compounds which contain this group, we call them carbonyl containing compounds. For example, aldehyde. Check this. This is the general formula of aldehyde. What is this? Carbonyl group. Ketone. This is the general formula of ketone. Carbonyl group is there. Esters. Carbonyl group is there. Anhydrides. Two carbonyl groups are there. Amides. Carbonyl group is there. Carboxylic acid. Carbonyl groups are there. So these are carbonyl group containing compounds. Can all carbonyl group containing compounds create alcohol with grignard reagent? No. Note down. Carboxylic acid, RCOH, and amides, RCONH2, will not create alcohol with grignard reagent. They react differently with grignard reagent that I will discuss later with you. In this video, I am going to discuss only those carbonyl compounds which will react with grignard reagent to produce alcohol. So carboxylic acid and amides will not be used to create alcohol with grignard reagent. Let's start. How carbonyl containing compounds react with grignard reagent. I am taking example of aldehyde, RCOH. Very easy it is. First of all, we need to understand carbonyl group. Carbonyl group oxygen and carbon, two bonds are there. We know one is sigma bond, one is pi bond. Oxygen is more electronegative than carbon, so both electrons are toward oxygen side. That's why oxygen is carrying partial negative charge. And because this carbon is losing its 2 electron, so it is carrying partial positive charge. Here we have Grignard reagent. What I said about Grignard reagent. Between R and Mg, there is a covalent bond, and electrons are toward R side, means carbon side, and it is carrying negative charge. Means R is working as a nucleophile. It is looking for a positive particle. That's it. This is the main point. Here we have a carbon of carbonyl group, which is a positive particle. Here we have a R, which is a negative particle from Grignard side. So this R will attack on this carbon. This is a initial attack, nucleophilic attack. This is the main point. Now, obviously, when R and Mg bond will break, both electrons will go with R because carbon is more electronegative than R, magnesium. When it is going to make bond with carbon, pi bond will break and both pi electrons will shift toward oxygen because oxygen is more electronegative than carbon. So, next condition will be this. Now, because oxygen got one extra electron of the carbon, so it will carry a -1 charge. Previously, it have a 2 lone pairs. Now it have 3 lone pairs. And this R is going to make dative bond with carbon. H is as it is, this one. Here the hybridization of carbon was sp2. Now its hybridization will change to sp3. What about this oxygen? It will be satisfied by this magnesium. Watch. This magnesium was carrying +1 charge, which was satisfied by -1 charge of X. Now when one electron of magnesium will go toward carbon, so magnesium will release out as Mg +2. X negative. +2 cannot be satisfied by -1, so it requires one more -1 charge. Here we have. This will be the condition. +2 charge of magnesium is satisfied by -1 charge of oxygen and -1 charge of X. Ionic bond, ionic bond. This product is known as addition product. Actually, the reaction which is happened over here, this is nucleophilic addition reaction. Nucleophile was added first, followed by addition of electrophile. Yes, this is electrophile. Magnesium is working as electrophile. So this is nucleophilic addition reaction because it was started from nucleophile. And the product which we got, this is addition product. Do we want this product? No, we want alcohol. So second step you need to perform here to produce alcohol, which is very easy step and we know about it, hydrolysis. Apply hydrolysis. Now what is hydrolysis? In previous videos we have understood it. Breaking bond with the help of H positive and OH negative. Now which chemicals can carry out hydrolysis of a molecule? You can use directly a boiling water, H2O, because H2O can provide H positive and OH negative. Dilute acids can carry out hydrolysis of any molecule, or dilute base can be used to carry out hydrolysis of any molecule. So during hydrolysis, what will happen? This H positive will attack on complete negatively charged oxygen. OH negative will attack on complete magnesium positively charged particle. So attack due to this hydrolysis, this bond will break. And your oxygen will combine with H. Rest molecule will remain as it is. And your magnesium will combine with OH like this. Watch this molecule, alcohol. Alcohol is generated. What is the degree of this alcohol? OH is attached to that carbon which have 2 carbons directly attached with it. So it's a 2-degree alcohol. And this we call basic magnesium halide. Basic magnesium halide. Now next point here. Point of attachment. Suppose I have a aldehyde CH3COH, ethane 1-ul, and I am going to react with this grignard reagent, MgBr. What will be the name of this grignard reagent? This is the R part, which is cyclopentyl part. So name will be cyclopentyl magnesium bromide. Now be careful. This is the important point. Magnesium is connected to which carbon? This carbon. Means this carbon is partially negative. So this carbon is working as a nucleophile. Obviously this carbon will attack on this carbon because it is a partially positive. This is the main point. Alkyl groups will contain many carbon atoms. But through which carbon atom you will attack? You will attack through that carbon which is connected with magnesium, not others. This is the important point. Rest we know. When it will attack, pi electrons will shift. O will be attacked by magnesium part and this group will join with carbon. So after this attack, addition product generated will be OMgBr. H is here. Now watch carefully. I will join which carbon? This carbon I am joining with the carbon. This carbon. This is the important point. One more example. Like suppose I have a grignard reagent CH3, 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 CH2, MgCl. This is a grignard reagent. And here I have aldehyde CH3, CH2, COH. Partial positive, negative. Now which carbon is negative here? The carbon which is connected with magnesium, means this carbon. This is partial negative. So obviously bond will break from here while attack. So this negative carbon will attack on this carbon. Pi electrons will shift, which will be attacked by magnesium. So the product generated will be CH3, CH2, CO. O will be attacked by MgCl. H is as it is. Now watch carefully. I will join this carbon with this. So compound will be, carefully we will draw it, this. Hydrogens I am not drawing. You can write hydrogens. Okay. 2 hydrogens will be there. 3 hydrogens, 3 hydrogens and 3 hydrogens will be there. Check carefully. So this is the important point. Point of attachment. The carbon which is directly bonded with magnesium, that you have to use to attack on carbonyl group, not others. Okay. Now the same mechanism you will apply for ketones, esters, anhydrides, acid halides. Means two-step reaction it is. Means carbonyl group first react with RMGX, will give you addition product. This is addition product. And in second step, you need to perform hydrolysis. After hydrolysis, we will get alcohol. This one. Now, which alcohol will generate 1 degree, 2 degree, 3 degree? It depends on the compound, the reagent which we are using. Like if we are using aldehyde, so 2 degree will generate. If you are going to use ketones, so please check 3 degree alcohols will generate. Okay, try by yourself. Now the next point, one more point. When we are dealing with ester, anhydrides, and RCOX, acid halides. Their reactions will get completed in two steps of RMGX, means two RMGX are required. Aldehyde and ketones will complete their reaction with 1 mole of RMGX, but they will require 2 moles of RMGX for the complete process. Please check. Suppose I am taking example of ester. This is ester. Let's react it with RMGX, grignard reagent. Negative, this carbonyl carbon positive, oxygen negative. So obviously R will attack on C, pi electrons will shift toward oxygen, which will be balanced by Mg. So the addition product we are going to create will be this. Check carefully. This will be the addition product. What condition it is? I believe we have discussed this condition earlier also. One carbon carrying two oxygens with a lone pair. These are the two lone pairs over oxygen. Here we have three lone pairs. One carbon containing two oxygen. Is it a stable condition? No. Highly unstable because of steric hindrance. Two lone pairs are very close. Oxygen atom will feel steric hindrance, crowding problem. So one oxygen will get eliminated out from here. This oxygen is breaking bond from carbon, and obviously electronegativity of oxygen is more than carbon, so electrons will go toward carbon. Vacant orbital will generate, which will be satisfied by this pair of electron, which will be delivered by the neighbor oxygen. So after this, don't you think we will get this? And this RO negative, MgX positive, they will get separated out. Check this. What it is? It's a ketone. It's a ketone. Means ester, when reacts with first molecule of RMGX, will generate ketone. And ketones still have a carbonyl group. What does it mean? It means it can again react with RMGX. Another molecule of RMGX will be utilized to react with ketone. Check please. Two molecules of RMGX are going to use. First molecule of RMGX will convert esters to ketone. Now second molecule of RMGX will react with ketone to give us alcohol. How? That we know. Let's check. Ketone is generated. Now this is the second molecule. Same mechanism. Ketone. RMGX. R negative. C positive. O negative. R negative will attack on positive carbon. Pi electron will shift. Mg will attack. Same mechanism. R, C, O. MgX. R. R. This will be the addition product. Now this compound do not have a problem like previous one because oxygen is not available here. In previous molecule, what was the problem? We were getting this condition. This one. Two oxygen atom on a same carbon. Unstable condition. But here we don't have two oxygen atom. Here we have only one oxygen. So this molecule will not rearrange itself. It will remain like this. And finally, what process we will apply here? Hydrolysis. In this case, we didn't get a chance to hydrolyze it because it is highly unstable. Quickly, molecule has changed itself like this. But here, molecule do not have that steric hindrance problem. So now we can apply hydrolysis. H positive, OH negative. H positive will attack on O, Mg will be attacked by OH negative, and finally you will get RCOH, R, alcohol. And what is the degree of alcohol? Please check. OH is connected to the carbon which is further connected with 3 carbons with 3 degree alcohol. I already said to you, ketones will create 3-degree alcohols. Aldehydes are creating 2-degree alcohols. Side product, basic magnesium halide. Same mechanism is there with anhydrides, RCO, and acid halides. This one, same mechanism. 2 molecules of RMGX will be required here. Let me show you. First RMGX, positive, negative. R negative will attack on this, pi electrons will shift. Condition will be O, MgX, R will join here. This is the product which we are getting. Check. Do we have stable condition? On a single carbon, 2 oxygen atoms are there again. Repulsion problem. Bonds will break. Again, you will get ketone first. We are getting ketone. Means 1 molecule of RMGX reacting with anhydride, which will firstly create ketone. And now this ketone particle will again react with second particle of RMGX to give us, followed by hydrolysis. Directly I am applying here hydrolysis also. Hydrolysis will give you 3-degree alcohol. Same process is here with acid halides. Let me show you. RCOX, RMGX, negative, positive, negative, pi electrons will shift. RCOMGX, R. Now X. What is X? X in chemistry are halogens. And when halogens are making single bond, they always carry 3 lone pairs. And this oxygen, we know it also carry 3 lone pairs. The same problem. If oxygen were there, steric hindrance was there, na? If X is there, still have a same problem, 3 lone pairs, lone pair, repulsion. Again, the same process will happen. X will get eliminated out and the vacant orbital will be satisfied by oxygen. Again, you will get first ketone. And this ketone will react with another molecule of RMGX to give us, followed by hydrolysis, will give us 3-degree alcohols. So aldehyde and ketone will react with 1 particle of RMGX followed by hydrolysis will give you alcohols. But ester, anhydrides and acid halides require 2 particles of RMGX, 2 moles of RMGX, because with first mole it will give you ketone and the ketone will react with second RMGX particle to finally give you alcohol, which will be a 3-degree alcohol. Now let's solve some reactions. Like if we have this case, going to react with, let's take example of this case. What will be the product? And reaction can be written like this also. This is the first reagent and secondly you have to perform hydrolysis. Note down H3O positive is the symbol of hydrolysis, means dilute acid. So first you need to react this molecule with this grignard reagent followed by hydrolysis. So what will be the product? Solve it. This is the carbon which have a partial negative charge, is going to react with positive charge particle. Carbon is there. This is the carbon. This is oxygen, negative. It will attack on this. Pi electrons will shift. And please join them carefully. MgBr will attack on oxygen. Check mechanism. Now this carbon I am going to join with this carbon. Cl will be as it is. Now, because this oxygen is carrying 3 lone pairs, negative charge, here also we have 3 lone pairs, repulsion problem, Cl will get eliminated out. And firstly, we will get this. What is this? Ketone. This is the carbon, O and 2 R groups are there. This is ketone. Now this ketone will again react with same Grignard reagent, MgBr. Because still we have carbonyl group, it can react with Grignard reagent with the same fashion. It will attack on this carbon because this carbon is negative, pi electrons will shift. So OMgBr, and here we will have our another cyclohexyl group, this one. Now next process, hydrolysis. After hydrolysis, this MgBr will be released out. At the place of this we will have OH. This is the alcohol which will be generated during this process. So please try reactions and try to solve them, because only just watching this mechanism will not help you out. You need a practice of the reaction. So take your book, check exercise based on preparation of preparation of alcohol through Grignard reagent, and try to solve those reactions. Thank you very much for watching the video.